My name is Farni Boten. I am with T-Mobile US, and I'm based in Overland Park, Kansas. I'm also the ZSM NOC chair. NOC is the Network Operator Council, an advisory group in which all of the operators in the ZSM ISG are a member of. The NOC meets once a month to discuss concerns we may have with the ZSM progress and to make sure that we have one voice regarding priorities. In this session, I'm going to cover at a high level the ZSM requirements, architecture, closed-loop automation, network slicing, and security. The requirements for ZSM is captured in ZSM 001 specification. The scenarios in ZSM 001 are documented as a collection of short stories of operators' pain points and challenges with managing the network of 5G and beyond. The business requirement in ZSM 001 are used to derive the reference architecture framework in ZSM 002. The goal is to create a framework that supports a complete automation for managing a multi-vendor network and that is flexible, future-proof, and standards-based. For the purpose of document readability, the scenarios and requirements are grouped into several categories in ZSM 001. The first category is the automation of end-to-end network and service management. This category focuses on the automation of the operational task of end-to-end lifecycle management of network resources and services, from installing to commissioning to day 2 operations, upgrades, and decommissioning. There are several scenarios captured in this category, and example requirements include the capabilities to perform automatic management for compute, storage, network function, and for all domains, including the RAN, transport, and the core. There's also a requirement for that upon detecting a fault exception from the network, ZSM is to automatically perform troubleshooting and to perform the remediation to fix the issue. There's also a requirement in this category to have the capability to expose the management interfaces to third parties and a capability to locate the resources that are the bottlenecks for a given end-to-end service. The second category is the end-to-end automation of 5G network slice management. This category includes requirements to reduce time to market and management efficiency of network slice instances. So example requirements in these categories include capability to clone network slice instances and capability to scale network slice instances. The next category is the analytics and machine learning. We have a lot of requirements that are captured in this category that are related to predictive analytics, real-time monitoring and analysis, zero-touch self-optimizing network, self-learning based on reinforcement learning, and supervised and unsupervised learning for closed loop. Although we all want closed loop automation, some operators also want the ability to intervene the automatic fix, review the suggested changes, and either manually apply the change or let ZSM to proceed with the change. This manual intervention would be needed at least until the level of confidence to rely 100% on the AI algorithm used in the closed loop. The next category is the automated testing. An example here is to have a set of test procedures that would be automatically executed after a software install. different types of test procedures would have to be orchestrated and executed depending on the action that took place. So, for example, a set of interoperability test procedures would be executed upon configuration and routing changes to validate the messages between two or more network functions. Or a set of end-to-end test procedures would be automatically executed upon a complete end-to-end commissioning of network slice instance or a voice over NR service in the network. This could be a part of a loop where if a test validation fails, it would trigger appropriate changes to the network and resume testing if appropriate. NAS lifecycle and exposure with slicing is the next category. And this is an example requirements for ZSM framework to support managing the lifecycle of the network capabilities exposed to external domains and provide an interface that hides the internal network details. The next category is collaborative and federated service management. This grouping is about supporting network management across operators or partners. An example requirement here is to expose ZSM management services across multiple operators. Security. We have a few security business requirements that are related to the capability of ZSM to troubleshoot encrypted traffic. And integration and interoperation. Example here is the ability to support interworking with legacy management system. The scenarios analysis derives architectural, functional, and operational requirements. This is the ZSM reference architecture as defined in ZSM 002. In the bottom here, there are the network resources that are being managed. They are the network elements, and they could be the eNode B, the UPF, AMF, the physical network function or virtual network function, or the cloud infrastructure, etc. Whatever you want to manage. Within the ZSM architecture, we have the management domain. It implements a set of capabilities defined by ZSM, which includes the domain control. Domain control allows ZSM to make changes or configuration upgrades on the managed resources. Domain orchestration handles the lifecycle management of the managed resources. Then we get domain intelligence, which is the machine learning and AI capabilities of ZSM. Domain analytics derives insights from the collected data. Domain data collection collects assurance data from the managed resources. And we also have data services, which is responsible for storage, retrieval, and processing of data. The end-to-end service management domain in the top represents the management of an end-to-end service, which is essentially a composition of several management domains. The end-to-end management domain also holds the service level metrics and KPI, while the management domain holds the KPI for the specific network elements. The integration fabric. Here we have integration fabric, and the communications between the management domains should go through the interdomain integration fabric, which is responsible for authenticating, authorizing, service registry and discovery, etc. Common Data Service, or the CDS. The Common Data Service is a common place to store management data such as assurance, tracing data, configuration, and topology data. This architecture is designed to be flexible to support the evolving technologies and ZSM requirements. The ZSM reference architecture is designed for closed-loop automation, and it is optimized for data-driven machine learning and artificial intelligence algorithms. It follows the architectural principle that the architecture must be modular, flexible, scalable, and extensible service-based architecture. It supports separation of concern, where each domain is defined with its own scope and expertise. The architecture must support model-driven, open interfaces, and intent-based interfaces. It enables adaptive, closed-loop management automation, where the automated decision-making mechanism can be bounded by rules and policies. The architecture must support stateless management function. It must be resilient and must support functional abstraction. The ZSM architecture defines management services which can be provided and consumed by management functions. ZSM 002 defines about 45 management services in the specification. There could be several of these management domains in the framework, and their scopes are defined based on the separation of concerns in management by the operator. For example, the management domains could be defined to manage the RAN clusters in the various regions nationwide, the regional EPC, IMS core, etc. Or they could be defined based on infrastructure type, vendors, or operational ownership. This is designed to allow flexible management responsibilities defined for a network operations center in a specific region, for example. The resources and services are managed based on the scope defined. The same resources for a managed entity, for example, a performance metrics for a UPF, should not be managed by multiple management domains. Management services from other management domain can be consumed by any management domain. Interaction between management domains are allowed. The scope of the end-to-end service management domain spans multiple management domains. The end-to-end service management domain represents the management of an end-to-end service, and it coordinates the interaction between management domains. Communication between the management domains should go through the integration fabric. The integration fabric is responsible for authenticating and authorizing both the producers and consumers for the services. It provides service registration and discovery function. The integration fabric can support either a synchronous or synchronous pattern, such as RESTful request response notify pattern, or streaming data, which is the publish subscribe patterns. ZSM supports direct invocation between management services without going through integration fabric. For example, for a case where the solution is provided by the same vendor or product, where direct invocation internally within a product is more efficient. This is an illustration of how the components within the ZSM framework interacts with each other to form a closed-loop automation enabled by the management services defined in ZSM 002. Here we have a fault event or a network exception that is reported from the managed entity. In this case, it could be an AMF or UPF. It indicates that S-Gateway is not responding. The domain data collection receives a notification from a managed entity, in this case with the specific topic, with information about the fault event. The domain collection pushes the exception data to the integration fabric. The domain analytics consume the data from the integration fabric for further analysis, and the domain data services also receive the data for storage and other big data purposes. Based on input from AI and machine learning, domain analytics determines the root cause of the issue, which in this case is a bad link. It then provides the insight and pushes it to the integration fabric. The insights gets picked up by the domain intelligence. The domain intelligence determines the instruction on what needs to be done to fix the issues. The domain intelligence produces the configure resource service, and the domain control consumes the configuration instruction, and it executes the configuration changes on the managed entity. In this case, it could be the router to reroute the traffic. And the loop continues while the issue persists. There are 3 work items related to closed loop automation topic in ZSM. The motivation is to further specify how closed loop automation within ZSM framework can be realized. ZSM 009-1 is the closed loop enabler. It describes how to enable closed loop automation based on the ZSM architectural framework. It defines the different stages within a closed loop, how the different closed loop within ZSM should interact with each other, and how a closed loop could be configured by an external entity. This work item is a normative work item. It's stage 2, and it is expected to be finalized by end of this year. ZSM 009-2 is the closed loop solution. It describes the end-to-end solution of a closed loop automation based on the selected scenarios captured in ZSM 001. It would use the ZSM reference architecture described in ZSM 002 and the closed loop enabler in ZSM 009-1, and also identify the integration with the related managed entity, including collaboration with other SDOs and open source forum to support seamless integration between 3GPP and ZSM, for example. So this is a normative stage 2 work item, and it is expected to be finalized first quarter next year. ZSM 009-3 is the advanced topic for closed loop. This is a study item, which means it's informative, and it covers the advanced closed loop topics such as cognitive closed loop, adaptive closed loop, and intent-based closed loop. It also covers items that we could not cover in ZSM 009-1 due to timeline constraint. We have most of the needed building blocks in the ZSM framework that are defined in ZSM 002 that are necessary for network and service management that could be powered by closed loop. We want to further define the interfaces to allow for integration and interoperations between closed loops. The stages inside a closed loop is shown in the diagram here, and we have managed entity that is being monitored. An example is a UPF or SMF in the 5G core network. We have data collection function. For example, when an anomaly is detected, the data collection function is notified by the managed entity. The collection function would massage the data received and forward to the analytics function. The analytic function would provide insights based on the collected data. With the help from AI or machine learning, the analytics function would perform troubleshooting and determine the root cause analysis. The intelligent function provides specific decisions and recommendations based on AI models, policies, and intents. Recommendation is presented to the decision function, and based on the policy, the domain orchestration would automate the workflows to handle the management of the managed entities. The execution function in the control domain would execute the script to steer the state of the managed entities, for example, to change the configuration in the UPF or SMF to resolve the issues. The operators in ZSM collectively through NOC provided a list of requirements for closed loop to make sure that it is flexible and support multi-vendor environment, which is the list on the right here. It's a sample list. So a short list of the operator's requirements is listed here. And for example, making sure that the components that make up the different stages of a closed loop can be provided by multi-vendor components. So in this case, for example, an operator may have an AI system of choice and would like to plug that into the closed loop system instead of having each closed loop to include its own AI system. The operator wants the ability to manage the life cycle of each stages in a closed loop. For example, to start and stop the closed loop. We want the ability to prevent conflicting actions done by multiple closed loops on the same managed entity. We also want the capability for operator to intervene, presented with root cause and recommended fix, and operator can decide whether to allow ZSM to proceed with the fix, operator to manually perform the fix, or operator may decide to disagree with the recommended fix and perform a different fix instead. On the left here, we got closed loop enabler ZSM 009-1 that defines how the different closed loops within the ZSM framework interact with each other. Closed loop governance is a set of capabilities for external entities to manage the closed loop models and the life cycle of closed loop at design time and at runtime, and allow retrieval of information about the closed loops, such as the status and performance. Closed loop coordination is a set of capabilities that allows multiple closed loops running within the ZSM framework to interact with each other at runtime to satisfy the desired overall goal of the closed loop. The goals of ZSM 009-3, which is advanced topic, is to investigate the specifics enabling technologies to bring us to the next generation AI-powered closed-loop operations. We want to investigate advanced concept of closed-loop automation, such as learning and cognitive capabilities. The first area that we investigate in the advanced topic is how to bring us towards cognitive closed loop. So this essentially considers the integration of machine learning techniques to create cognitive closed loops. A base proposal that we are considering is by looking at cognitive MAPE, an acronym for a well-known closed-loop model. MAPE stands for Monitor, Analyze, Plan, and Execute. It incorporates machine learning in each stage of the closed loop. For example, it incorporates machine learning in Monitor in order to perform intelligent probing. It incorporates machine learning in Analytics to predict changes in the network, and may incorporate machine learning in Execute for optimal scheduling for planned execution. So this approach makes the closed loop more adaptive compared to the traditional closed loop that are usually self-regulating but not self-learning and do not adapt to changes in conditions. Adaptive automation is the dynamic and informed allocation of management functions between human and machines. This allows for the trust of the machines by the human as it reaches maturity in machine learning. It is similar to the concept that we have a trainee engineer needing closer supervision, and as he becomes a senior, more experienced engineer, his decision is more trusted and will no longer require supervision. In this case, the engineer is the machine and the supervisor is the human. Intent-driven closed loop is about dynamically creating a closed loop based on the business intent in a service creation. So, for example, as a new service is created, it may include information about the intended performance, and the closed loop would be dynamically created and activated with the appropriate stages and data collection function to monitor for the performance of the service. As I mentioned before, the advanced topic is a study item, and it is expected to complete in first quarter next year. ZSM 003 captures the end-to-end management and orchestration of network slicing that span multiple management domains. There are several roles defined in network slicing. So for example, the customer role or CSC, we have service provider role or CSP, and the network provider role or NOP. There are many ways that the communication service network slicing can be offered. So there are two typical scenarios. First scenario is called NOP internal. It is when one entity, for example, operator X, takes the roles of both the NOP and CSP, and it is providing the communication service directly to its vertical user, the CSC. In this case, the customer does not have the visibility of the network slice. The second scenario is network slice as a service, where a network slice is offered as a service by one NOP and CSP entity, right here, which is entity A, and the service is used by another NOP CSP entity or the entity B to offer the communication service to B's customer. The management of network slicing architecture is based on the output of ZSM 002. It is an instantiation of the ZSM reference architecture with network slice as an example. The end-to-end network slice architecture has 4 major components. We have the end-to-end service management domain, and to provide the end-to-end network slicing related management services. It is also the consumer of the management services provided by the RAN, core, and transport management domain. We have the corresponding AN domain right here, which is the provider of the access network slice subnet related management services. We have the CN domain, which is the provider of the core network slice subnet related management services, and the TN domain, which provides the transport network slice subnet related management services. ZSM 003 captures the end-to-end network slice solution, including detailed procedures and call flows, such as the lifecycle management of the network slice, the provisioning with transport coordination, and performance management of network slice. The security aspect study item is captured in ZSM 10. It aims to outline a list of security controls or countermeasures in order to raise awareness of security aspects that could be considered in ZSM specification. The report will explore the relationship between security controls and technology-specific solutions. The motivation of ZSM 10 is based on the problem statements that the threat surface is extensive in ZSM environment because of the openness of the ZSM framework and the nature of the emerging technologies. That compromising a ZSM system security may adversely impact the operator network and the vertical service provider, and that the compliancy with local, regional, and industry security laws and regulation is an obligation for service provider and their suppliers. The scope of ZSM security includes the end-to-end service management domain, the cross-domain integration fabric, and the cross-domain data service. And the objective is to identify security threats and to propose consideration to be handled by the ZSM work, to identify and share best practice countermeasures related to the identified security threats, and to provide recommendations and guidance for further ZSM standardization activities regarding security aspects. Early draft is available, and the final draft for ZSM 10 is expected by end of this year. This concludes my presentation, and thank you for listening.